All right, so the first thing you should do when you get a brand new calculator, especially if it's not yours, you should press second plus 712 to reset. Okay, so we're gonna go ahead and make sure we reset our calculator. So I'm gonna grab mine. I'm gonna turn it on. Second plus 712, and bam, it's reset. We're all good. All right, so now it wants us to create a model of what we just did. So on in your notebook, it should be on the left-hand side, we created a table, right? We created a table of length, width, and area, correct? Am I making this up, or we all know what I'm talking about? This guy? Okay, so we have our table, and it wants us to create a equation using width and area. So the only values from our table that we're going to focus on are the width and the area, and see what is the relationship between that. And the reason being is because if I know the width, I can always find the length. Does that make sense? Because we are working with 2400, so you don't have to graph and analyze both. So in our table, we're going to put our width values in. So we're going to go here. Remember, to put in our table values, we're going to go to stat, edit, and we're going to input our values. So I have 100, 200, 300, 400, 500, and 600.
We're on the left page still?
We're using the table from the left page.
No, like I thought for a second I thought I saw the part two and I got confused. We're still on part one, right?
We're using the table from part one.
Oh,
Yeah. All right, and I'm gonna keep filling in the values. Yes, we're putting our area in. I did not put area. Remember, the K means that it's actually in the thousands. I'm hoping I'm putting enough zeros. Skip to 0.
How many zeros go?
The K is 3 zeros. 270,000, 320,000. Zeros are tricky. 350,000. Less talking, more following along. Emma, Ren. All right, I think I got all mine in. Nope. We've already talked about that. We already talked about resetting your calculator, so there shouldn't have been anything in there. It's a lot of zeros. Does it look like that?
You don't put like the actual number.
Years. When you're talking about years. That's only mainly for exponentials. You can do it with everything else. It's just with exponentials, it gets entirely too big.
So why don't
Because if you know the width, you automatically know the length, and you only have 2 variables when you're calculating a function.
So the calculator?
No, but you do know. If I know I have 100 is my width, then my length has to be
So I
1100.
could technically put length too, if I did one, but I don't want.
Yes, you can choose one or the other. All right, so we put in our width and our area, and now we're going to calculate the regression. So before we do that, I want to go over with you on what it looks like. So here it says we would use Desmos to calculate this, and it was you have to input it into Desmos. You'd have to remember this little Q code on how to put into Desmos. But we're not doing that. We're just sticking to our calculator. So in our calculator, to get our regression model, we would have to go to stat, calc, and we want a quadratic regression. Quadratic regression. So that would be 5. So if you see right here where it says quad regression, remember 4 is linear, 0 is exponential, and now we realize that 5 is quadratic. So I'm going to press 5 for quadratic. Yes. Okay. Nope. You're gonna go store reg. So the more I've like looked through AP testing and where they're at, they want you to have the most exact all the way through. In order for us to have the most exact values all the way through, you're gonna have to get comfortable with storing it because there's too many variables for you to have to type it all out. Does that make sense? Your final, it wants it, but while you're working, they don't want you to round to the end. Does that make sense? So when we're calculating this, we want to get comfortable with storing the regular regression equation. The reason why is that the calculator will hold those values for us, and we know that we're being more precise into the end. Does that make sense? So in order to store, this is very key. You're gonna have to press vars. So we're gonna press, once you get down to store reg EQ, we're gonna press vars. And we want to create a y function. So we want to say y equals. So we're going to go to y variables because we want to be in y equals. And we're making a function. So the names that go along with what you're pressing make sense. So we want to create y variables. We want to create a function. And I want it to be graphed in y1. So again, all I did was go vars, y vars, function, y1. And then I will calculate. Okay. Now, luckily, these are some easy numbers to work with, right?
Yeah.
And so we know that these are our exact values because we're not rounding, and we know that the calculator is storing it for us. So our equation here is, these are our parameters. So our parameters are A equals -1, B equals 1200, C equals 0. So we're just plugging the parameters into where they go in standard form. Do we see that? So our A is -1, our B is 1200, and our C is 0. So that's what I'm going to write out. So we have y equals -1 x squared. And again, I'm not making it up. I'm just going straight from here. Plus 1200x, and just for the sake of consistency, plus 0. Oh, so C for 0? That's what it came out to be. Or C equals 0. Okay, so when we look at this, how is this similar or different to what we came up with? Well, when we think about this, we realize that our 1200, wasn't that what our one length and one width had to equal? They had to equal 1200, right? So thinking about what we came up with, the reason why it's a -1 for our A is because our values are doing what? They're increasing, and then probably are going to go back decrease because my length and my width can do what? Switch places. So right now I have shorter width, but I can get here and I can have longer width and shorter lengths. Okay. So how does it relate? Well, it relates to the fact that it all makes sense. It all is coming together. How can you use the regression equation and its graph to determine the dimensions of an animal pen with its greatest area? So if you're looking for the greatest area, so if I need the greatest area, that's called our maximum value. So we're looking for the maximum value. And in order to look for the maximum value, we're going to look at our graph. Okay. To get our graph with our values, remember you want to press zoom 9. Okay, so we're going to go look at our graph, and this is going to lead us to our graph with all our values. So I'm going to go here.
Yeah.
Yeah, it's a straight line on.
Yeah, once you zoom out, it's not a straight line.
Zoom 9. It's going to think about it. And it shows me.
Mine's already straight line first, and then once I change the window.
Yeah, so we're good. So when I did zoom 9, it thought about it. It's thinking this little ticker.
Is your plot 1 on?
And then, oh, my plot 1 is not on. Thank you. Plot 1 was not on. Good call.
I saw Lydia. You had it done that stuff.
I had gone to plot 1. Thank you, Lydia. All right, forgot to turn my plot 1 before I zoomed anywhere. My bad. Human error. I'm a human. All right, so yes, go to Y1, Y equals, and we're gonna turn on our plot 1, and then we will press zoom 9, and everything should come into play.
Okay.
Sorry. I'll take a lesson. All right. I would have figured it out, but I didn't have to think too hard because someone else saw it for me. Just like when y'all make an error, you call me over so you won't have to figure it out. All right, so here we only can see the values that we had, right? And so once we get here, if we're looking for the maximum value, we are going to need to zoom out a little bit more to be able to see the full quadratic. In order to zoom out to see the quadratic more, you're literally going to go to zoom, and you see where it says zoom out. That's zoom 3. So we're going to go to 3, and you see a little blinking cursor right here. You want to move it in the direction you want it to zoom out towards. So I wanted to zoom out a little bit more to the right. So you notice how I move that cursor to the right to give an idea of where I want it to go. And I'm going to hit enter. And it's like, does this work for you? I'm like, yes. I can now see the full negative quadratic.
Oh, wow. So,
We zoomed out. That is your maximum.
Wait, how does it get over?
press 3.
And zoom out.
Get this cursor, move it over to the right over.
So you zoom out in the direction that you want the graph to go. Does that make sense?
Oh.
Okay. So now when we're here, from our table, we already know what our maximum value is, right? What was our maximum value? Looking at your table. It was the 600 and the 360,000, right? So if I have a length of 600 and a width of 600, my area is going to be 360,000. What this is just going to show you is that you were correct. So in the calculator, in order to find our maximum value, I'm going to write it down before I do it. We're going to press second. Then we're going to press trace. So second trace comes by right here. See the guy right there? And we're looking for the what value? Maximum. Does it say maximum? And when we press second trace, and it says maximum. Okay. So at the very top, now this is a little tricky part. When we're there on the calculator, I like to call it the cha-cha slide. We're going to go to the left, and then we're going to go to the right, okay? What you're telling the calculator is where you want it to estimate your maximum value at. So we know that our maximum value is somewhere in here, right? So you can't really see my little blinking spider, but it says left bound. So it wants me to go, I go like 4 clicks to the left. And I'm going to press OK. Then it says now go right. So as I'm doing it, it says go to the right. I'm going to go enter. Your OK is entered. And then you can see my little spiders now to the right. What this is doing is you're giving the calculator an area of where the area is located, where the maximum or minimum is located. So it says, so you think your maximum is somewhere between here? I'm like, yeah, my maximum is somewhere between here.
Oh,
Okay. And it's like, so you want me to guess? I'm like, yeah, that's why I did it. It's just like a rough estimate of 4. It just depends on where your cursor is. And then go to the left. Okay. In order for it to stay left and right, you have to enter. And then hit enter.
So that's my maximum.
So your maximum value, and it'll tell you, it'll say maximum. So it'll say maximum, or it'll say minimum.
Just the X.
Okay. So our maximum, yes. It's okay. Yeah, you're okay with 600. 599.99999 is 600. I was like, that's 600.
How'd you pull that up, the maximum and the minimum?
Second trace.
Wait, so where are we writing that down?
Okay, so on number 2, it says, what is your maximum? And the maximum size of our pen is
I not make profile? Cause you're always going to do is just.
Yeah.
So I-
You're right.
So that's my number.
So if x equals our width, and our maximum width value was 600,
Right. Oh, oh. Oh, so I was like, okay.
okay? So if our width is 600, then that means our length is 600, which we already had figured out from a table, right? Okay. To show you the steps to do it when the numbers aren't as friendly.
Oh.
Okay.
Wait, so what would be a case for the number?
The next problem we're gonna do,
Oh.
Yay. okay? But we're going through the steps with a problem we've already done by hand so that you can see that we're accurately doing it. Does that make sense? Okay, so we already knew what our answer was gonna be, but we're showing you how the calculator can model that for you. All right. Then the last thing we're going to talk about is putting it into vertex form. So we talked about 3 forms of our quadratic, right? Y'all remember doing this? The 3 different forms. So we have standard, factored, and vertex. Okay. So if a problem asks you what is it in vertex form, in order to be in vertex form, we would have to know our maximum or our minimum and our a value. That's all you need to know. Well, in parts 1, we found our a value. What was our a value? -1. In part 2, we found our maximum value, and our maximum value was at 600, 360,000. And so we have all the pieces we need to write it in vertex form. Because remember, vertex form is y equals your a times your x minus your h plus your k, and I forgot my square. Okay, and h and k are your vertex, and your vertex is either going to be a max or a min. And in this case, it's a what? Maximum. So all you're doing is plugging those values in. So we have y equals -1, x minus 600 squared plus 360,000. Okay, our -1 came from here, which was our a var. And a is the same for every single one of them, right? A doesn't change. If you want to. Huh? Length is the same thing, but length isn't part of our table. H and K are your, so last week we talked about H and K represents the vertex of your function. So it's your max, whatever your maximum.
So it's 600 and then 360.
Because that's where our H and our K, our maximum was at. All right, so tying it all together, making sure you understand, I'm going to pause and I want you to read through and answer. So looking at 1, 2, and 3, I want you to discuss what is the vertex of the parabola? What is the maximum value of the quadratic? And interpret how does this mean and what does this mean based on how we did this problem, okay? What is that information telling us? So we're done with the calculator. Now it's time for you to put on your thinking cap and summarize our learning, okay? So what was the vertex? What was the maximum? What did it mean for this problem? Okay, so I heard a lot of good conversations from people who tried to stay on task. So when we are summarizing here, your vertex is the point, our maximum value, our highest point at the top. And when we talked about the vertex, we knew that it was 600 and 360,000. Okay, your maximum value when you're referring to value and anything, it's actually the y value only. So the maximum value here would be our 360,000. Value.
So the 600 is the Y?
The 600 is your width. It's your x. But your value comes from your y. Okay.
It said 600.
It just says your maximum. It didn't say maximum value. Your maximum point is here. Maximum point and maximum value are slightly different in math.
So the vertex was off the one.
Yes.
So whatever the bigger one is for maximum value, so the Y.
The y of your vertex is your maximum value.
Oh.
So like we have our vertex, but when it says what is a maximum value, that is the y. It's the y of the two. Okay. All right. And so in the sense this tells us, which we already knew, is that 360,000 was the maximum area that we could have for her pen, right? And which we already knew because we already saw this by hand, and because these are kind of an easier number with a set situation, set domain that we could work. Does that make sense? Yeah. All right. So now we're gonna go to the next part where the numbers aren't so friendly, and that we have to do a little bit more and actually fully utilize the calculator. Okay. I know.
I don't think you want to.
Here we go. It says articles often cite the most fuel efficient speed for driving a typical mid-sized car to be 55 miles per hour. But is this statement true? And if so, where did that information come from? In the late 1990s, the Federal Highway Administration conducted a study to compare the speed of a car in miles per hour with its fuel efficiency or mileage and miles traveled per gallon, their MPG. Okay, the following table was collected the data from the data. So if you look right here, we have if you drive 50 miles per hour in a mid-sized vehicle, that's 34 MPG, right? And it just keeps going. That's all the data that was collected. Now, what we're going to do is we're going to use our graphing utility to create a scatter plot, providing one reason why a quadratic equation might be appropriate choice to model the data, and one reason why a quadratic may not be appropriate. Okay, so before we get started, the first thing we should do is what? Clear our calculator. Okay, so we're going to clear our calculators by pressing what? Second plus 712. It sounds better when you sing it. All right, so my calculator is cleared. How am I going to input the data into the calculator? I'm going to go to stat edit. All right, so let's get to inputting. We have a little more numbers this time to input. So if you do it without talking, you go a little faster. No, you just go back over and type where it's or press the delete button.
Oh.
I feel like it's a lot faster if I actually have the handheld, but clicking the buttons from the computer.
We're doing the left one, right?
We're doing both.
We're doing both.
It's a continuing.
So we're just. You keep going.
Same.
Yeah. Like, that one, this one, yeah.
All right. All right, so I have all of my values in. Once I have all my values in, so let's recap what we did. We reset the calculator, and then so we reset. What are they doing in there? And then we went to stat. And I don't know what happened over there. I promise it's not me. But I'm glad I'm not alone when that noise happened. So we did stat edit. We input our values. Okay. After we input our values, then we're going to go to y equals to turn on our plot. So we're going to go to y equals. And we're going to turn on plot 1. So y equals, arrow up to turn on plot 1. You just press enter and bam, plot 1 is on. It's exactly the same things we've been doing the entire time. Nothing's changed. And we're gonna press zoom 9 to see our scatter plot.
Like a little M.
A little bit of a McDonald's sign. All right, so in part 1, it wants you to justify why we could use a quadratic. So give me a reason why a quadratic may work. And then you're gonna give me a reason why a quadratic will not work.
So we rewrite. Oh, wow.
Are you announcing names today?
Tomorrow. They have to be checked.
Okay.
Yeah. So why would a quadratic work, or and why wouldn't it work? Zoom 9. You weren't supposed to go over. Did you put all your points in? You must have only put one table in. You only put half the table in. You need to put both tables in. That's why. All right. So, who would like to share the reason why? Anyone? Or I have to call on. Let's see who's going to be the lucky winner for the.
Oh, I think wait, so we put both things?
Yeah, you're telling me why it would work and why it wouldn't work. All right, let's see. The winner is this person likes the color yellow. James.
Yes, James.
He likes the color yellow.
Hey.
Oh. So why would it work?
Because it has a maximum.
Okay, it appears to have a maximum.
It
Okay.
has 2. Wait, no, it has
It has 1, but then it also has a second one, which could be the reason why it doesn't work, right? So quadratic, in sense, all of our quadratics, they're either going to increase then decrease, or decrease then increase. And in the sense of this, for the most part, this graph does what? It increases and then it decreases. So that kind of fits the bill of a quadratic, right? Now, what would be our little hiccup?
The dip.
The dip, our little M, right? All right, our little weird looking M here may be our little hiccup, but that's what it's asking you. Just looking at the graph and analyzing is all it's wanting you to do. Does that make sense? All right. So all the things you could have said, student written. So again, this was your student opinion. All right. And really quick, I want us to pull up our regression, but I don't think we're gonna have enough time. What time to get out? In 2 minutes?
We have 1 minute.
Oh, okay. So we'll pick up here where you're gonna put in the graph. So tomorrow we're gonna finish talking about this. We're gonna do one more example. And then the rest is for you to practice.